My name is Giorgi Cheishvili. So I'm a software engineer, software developer from the Baylor software. And today I'm going to be trying to write cross-platform, cross-framework components using fundamental styles and a couple of other tools that we'll be exploring today. So as an UI kit developers, we face same question all the time. Like, how do we support as many frameworks and environments as possible with least amount of effort while also leveraging all of the advantages that those environments give? Like, after all people use those libraries and those frameworks because of those advantages and those specifics that those environments have, right? So for instance, I, as an Angular developer, went with Angular and love using it because of the toolchain that it has, because of the features that it provides out of the box, such things like HTTP client, for instance, or forms, which is a very good thing, or like just a sheer amount of the possibility that I can work on any Angular based application, and that gained knowledge is transferable to other applications and other projects. And then there comes the React guys, for instance. They love how easy it is to use, how explicit it is, the high performance of the thing, the flexibility that you are having, extensive amount of the third-party libraries and the huge community and so on and so forth. And there are many things why people choose certain frameworks, right? So everyone has favorite environment they prefer. And we as an UI developers, UI kit developers, always want to have like as many framework support as possible. We already have fundamental styles, which is pure CSS, HTML implementation of the Fiori and Horizon style guides. And right now, anyone can use it in any development environment, like it was already showcased in this conference today. But having to copy all of those things, having to write that much HTML is not efficient, right? So although it will do the job, it will be perfect from the outside and everyone will be happy. We as developers will always try to have better options, right? So to really understand how things are done in cases of other frameworks and other industry-leading libraries, I dived in and looked how people are doing it. So first, I approached the Kindle Ui. So Kindle Ui is a commercial UI framework, UI kit library, which supports four frameworks, namely Angular, React, Vue, and just jQuery. So how do they achieve that? They are writing components per framework, meaning that in case of the button, for instance, they have one implementation for Angular, one for React, one for Vue, and one for the jQuery. And same goes for all of the components. And as you may already understand that, it's a bit problematic, even though they can leverage all of the functionalities that those frameworks and libraries are giving. When you want to update something in some of your components, you have to update 4 times. And that's a bit problem because your effort is quadrupled. And if you want to add additional framework support, then add additional effort. So it's a bit problematic, although it does its job and you have full support of all of the features. Then I approached Ionic. Ionic is an hybrid application writing framework. So what that means that you can write one code and you can then compile that code into being either Android application or iOS application or any other platform that they will provide. And the writing codes part is interesting in this case because you can write that Ionic components in Angular, React, Vue, or just pure JavaScript with web components. And how they did that is an interesting and unusual way of doing. So for that, they created their own framework for handling such situations. They created Stencil, which is an open source framework for creating web components. And Stencil also has a one twist to it. It automatically generates the framework specific code. Like if you write Stencil component, it will first go to the web component, and then their automagic compiler will also create a wrapper for certain frameworks. And that's the key point here. Those are wrappers. Although I really like this approach and I really love what Stencil has done, what Ionic team has pulled off, I cannot fully love it because after all, those are wrappers. And remember, we want to use all of the features and wrappers from the surface can support all of the features, but not that greatly because let's take an example for the quick framework, which is rising right now and which is fundamentally different approach to many things. So with wrappers, you cannot kind of like split all of those things to be able to wrap properly inside Quick, as far as I'm aware, at least. So it does its job, but not that greatly that we might want to have it. Also, the thing with the web components is that IntelliSense is a bit problematic. Meaning that if you write them in your HTML, bare HTML environment, IDs will not understand always what's going on about them. And currently, to get IntelliSense, you have to generate JSONs. There is one JSON schema for Visual Studio Code. There is another JSON schema for IntelliJ, and also applying those JSON schemas to those respective IDs. The ways of applying them are a bit different. So in case of the Visual Studio Code, you have to use them in your project configuration and set up the settings. And in case of the IntelliJ, you have to create PR to their repository somewhere on the GitHub, and then all of the people that use ID and import your library will automatically understand the contents of your library. And even though if that hacky approach to the IntelliSense was acceptable and okay and good, then we would approach additional problem, which is how do you support then online IDs, and they all do things differently and there is no standard about it. And there are enormous amount of the web IDs. Even one of them was featured today with us. And other than that, there are stack plates, Code Anywhere, Replit, JSVDO, and many more. So the goal is pretty straightforward, is that to be able to write in one type of the environment and be ready for the changes, be ready for what comes up next, what is the next biggest name in the industry, right? So what could be the solution to that problem of ours? So solution would be to have an universal compiler, of course, right? So here's the mitosis. To achieve that universality, few smart people gathered and thought how such thing might work and how such thing might be even feasible. And they approached one solution, particular one solution. So anytime you write code, you automatically get AST, or abstract syntax tree. So what AST is that full tree data structure representation of the code that you write, and it can be parsed. But the problem is that parsing that for me and you might be a bit problematic and source of the big headaches because it's hard to digest, let's say. So they created their own JSON schema, and that JSON schema, I mean, their compiler is compiling that code to their JSON schema, and then they are using generators to properly analyze that JSON schema and generate per framework native implementation of those components. And that's an interesting part. So if we look at the mitosis.js JSON representation of file contents, it's fairly easy to digest. Just looking at this, you probably already understand what's going on in here and how would the end component would look like. Like we have declaration of the component, right? We have metadata that we can read with our eyes, like something special about this component, and we could probably use that flag to add additional logic to it, right? We also have like children. We have three nodes here, one h1, three divs with text contents of hello, additional code which uses prop, and there is a default value of world, and then exclamation mark, right? It's fairly easy to understand at this point. So the thing with mitosis is that it is one-to-one representation. Like if you have one component, if you're using compile command of theirs, it will be only bothered about compiling that particular component into your chosen target. So let's explore how that is done. And today I'll be using Enix and mitosis.js and fundamental styles for getting up quickly. So before we start, there are few problems with mitosis and Angular, and today I'll be mostly focused on Angular transpiling, compiling, because I love Angular, just like I have stated. So problem with Angular is that, remember I mentioned one component, one representation to the one component. In Angular, we have modules, and although Angular 14 has introduced standalone mode of the components, it's not, I mean, it's experimental. I mean, it's experimental of the experimental library, so I would expect, so it's not that stable at this point, but I'm sure that will be fixed. So we have button, and it will be button component. There is no generated module. That's a bit problem. There is no form support because it's just a raw compilation, and although it can be achieved, it's not out of the box. If you have like composite component, for instance, list or table or form item or something like that, because there is no modules, you cannot properly group them, and the compilation comes a bit strange, but it is what it is for now, and that's the problems that is existing related to the Angular. But there is a bright side. There are plugins. So the mitosis is extensible, so we can dive in and update some parts of the compilation process. For instance, remember I mentioned Json. You can update Json before mitosis generator adds additional entry points to that Json. You can also update that Json after generator modified some stuff. You can also update code, like the text itself, before Prettier gets hands on it, meaning that before beautifying that code, and also you can update that output code after Prettier, right? So it's a powerful feature. It gives you all of the things that you might want to have for such thing. And with that explanations, let's go to the code. And first of all, let's see how things are done. I mean, how I have befriended mitosis and NX. So here I have a few, well, not few, already a bunch of the components, but it was fun to do things, so I got distracted. So we have button, we have card, we have checkbox, and so on and so forth. And mitosis syntax is fairly simple. It really looks like React. It's not React, but it really looks like it. It resembles it heavily. I have few targets, as you might remember from Dimitri's talk. This is how it's used in real world. And this is how you create your custom executor for the NX. So to compile this library, I'm using my custom executor, which is inside the mitosis tools library. So what this gives to me is that anytime I want to do some repeatable tasks, those tasks will be cached. Those tasks can have like dependency graph, and also behind this target, I can have multiple different executors. For instance, in case of the button, it is to compile the component. And in case of the shared library, it is just compile shared, which is another thing there. So let's go to the mitosis tools, where actually those things are described. So here in executors, we see those two executors, compile and compile shared, and they have this implementation there. So if I go to the executors and compile, I will see the implementation for compilation. So here it's very simple because I'm not doing anything special here. I'm just collecting and adding the default flag to the target options. And then I'm calling to another thing given by the NX, which is generators. So generators are like a way to have templates in your application and have like safe way of generating code. It's much like the Angular builders, Angular schematics. And it's a very handy tool. This is how, I mean, I will go to the shared first. So shared is just taking those mitosis shared things. I did not even bother to attach any different thing. I'm just copying. It's just hard-coded value, but it is just taking source and copies to the output, and that's all about it. In case of the generators, the interesting stuff starts here. So let's first of all go to the Angular, not Angular, but mitosis config. So this is how you write for the mitosis, and this is the way how you use plugins. In this example for Angular, for instance, there were a couple of bugs here and there, and I had to have like this metadata store here for now, but it will be solved in near future. I have left debugger here. And so what we are doing here. So before generator goes in and updates some stuff to the JSON, first I'm going in and updating the JSON. So what I'm doing is that I'm matching the mitosis imports from the component and replacing them to the target framework imports. So those libraries will be fully encapsulated. It will not import anything outside of themselves. So I'm just replacing them here. Then I have used metadata hook provided by the Ionic, not Ionic, but mitosis, getting lost. And we have few things here. So we have control value accessor implementation. Remember, I said it doesn't support that. Well, I did that. It has encapsulation edition, and it has the uses, and it has the typings, custom stuff. I could have attribute selector on the component, or I could have something else. I'm adding prefix, and so on and so forth. So pretty basic stuff here. And in case of the React, I'm not doing anything special here. I'm just adding DOM attribute type to the props so that I have support for the on-click or something like that, so that it's not right there. And what I'm doing else. Also here we have files. So the generators have such a cool thing called like templates. You can use them. It's an EGS syntax. And I could just take these files and put anywhere I want them with these set values and variables to them. So that's basically it. Other than that, I'm just going into the target frameworks, and then I'm just going into the component. I'm saying that output file should be this, depending on these configurations that are also additional thing. I'm just resolving mitosis config, and nothing crazy here, but the result is crazy. So let's go and check out our application that is written on Angular, and all of the components that are not created in here are coming from the mitosis generated outputted components. So nothing in this application regarding the UI side is coming from the per Angular development way of doing things. So in app component, so it's a to-do application, you know, for talk, you should do to-do. That's the easiest thing to show. So we have to-do application, we have our FD list, we have our form group, we have our list item with like input control, which is just the control from control name is title and so on. We have filtered items, and we have this, and we have that, and nothing interesting about it. So visually, it looks like this. I could do things like that. I could do modify. How do you see it? I could say that some tasks are complete. I could then filter them out, do other things, like delete some stuff. There's nothing here yet, obviously. So from here, we can see that it's kind of fully workable application right here, right? All of the components are working flawlessly and nothing is red, I hope so. Yep, nothing is red. So what I want to do right now is to modify a bit how FT button is implemented. And let's go into the current implementation from the Angular side and what it does right now. So it is using just inline template, just styles, types, nothing more. But the thing is that here, FT type is this. I mean, button type is this. And I don't have possibility here to have emphasized and positive, I mean, positively emphasized button type, right? So let's suppose I want to update that and I want to modify the way that now my button can be both types. So what would I do? In standard development process, I would go here and extract that type from that union, add some Boolean input, and then it would just magically work, right? But in this particular case, I will do things differently. So because I also want to have updated variant of that button in React implementation, which is this. Do you notice how they look like each other? But yeah. So let's do the magic. So I remove emphasize from here. So here I don't have that anymore. Here I will have additional. So call it should be optional. So in the props I have now that value. If it's emphasized. That's all. So right now, what I'm gonna do is that I'll just launch compile. And if I'm launching that compile, it will just start and it will finish in a couple seconds. So Angular is already outputted and React is also outputted. So now if I inspect what's the output on the Angular side, we have emphasized input and we have that in the classes generation, and same thing goes to the, where was it? React. Same thing goes to the React side. So we have already, same thing goes to the React side. So with one commit, with one change, I was able to just modify the behavior of the button, modify the public API of it. Same could be said about any other component, like for instance, I have list component here. If I wanted to modify how it works, I could pretty much delete it and rebuild it for the two output applications without any dropping a thread, and it would not be a problem. So this is what the mitosis can do. And let's go to the imagining ourselves in some magical fictional place. Probably that happened to many companies, but let's discuss some stuff here. So let's imagine the company that has its own style guide, like Kindle Ui case, right? They support 4 frameworks right now. If for instance, they have decided to support another like Solid.js, they would have a Paint or Svelte or Quick or I don't know, any other. Because the way they do things, So after brief considerations, they would start multiplying their efforts, and results would be great for the users, but for the team, it would be painful. Let's imagine a situation in case of the, I don't know, Ionic. Like they would add additional adapter, they would add additional compiler to their structure, to their stencil, and it would work. Same way it works right now. But, well, case of the Ionic is a bit special because the framework they have is open source and it's usable outside of their headquarters. But in most cases, that's not the case. I mean, most companies don't do open source unless they are kind of altruistic about giving back to the developers. But in most cases, those are closed source. And if they have similar thing, they would just write some kind of additional compiler, additional adapter, additional generator, and that effort would be one time, output would be acceptable, but the thing is that it will be just redundant work because cool, they have it, but I don't have it. Cool, they have it, but millions of other developers don't have it. And their efforts is useless outside of that corporation, outside of that team, and outside of that particular project. Efforts are not shared. So we should kind of share, right? In ideal world, in my opinion, things like mitosis.js, where things like mitosis.js exist, those new frameworks and new libraries that are coming on a landscape would just publish adapters to old users of other libraries. Like, for instance, Quick appeared, right? They created mitosis adapter for it, although they are same team, but still, point checks out. They created adapter for Quick, and right now, if you had, for instance, in ideal world, UI implementation on the mitosis, you would be up and running right away because the adapter exists there. And you could just compile your UI to the Quick, and you would not have any issues with it, right? So the value of such plugins and libraries are huge. Like, let alone the support for the new frameworks, right? Let's talk about the breaking changes that the libraries give out from time to time. For instance, few years ago, using object-oriented style in React was cool. I mean, nobody would bat an eye. And now mostly people write in functional programming. And as far as I'm aware, even creators are recommending the functional way of writing components, right? If you had big library written on classes, you would have a big problem because you would have to do manual work. Although work is not that big of amount, it's still a manual job, you know? So in ideal world, we would have some adapter for it, and it would be automatically compiled. Same goes for the versioning. So today we had talk from the Eclipse guys who write in AngularJS, which lost support this year. So in ideal world, with sophisticated enough algorithms for transpiling things, they would just update the compiler and that's all. They would have output right away, right? And because of these reasons, and also the feature stuff, for instance, you have imagine the situation. You want to have you have UI kit written on some kind of mitosis-like environment, right? You choose target framework and you choose how you want that target to be managed. For instance, in case of the React, you have numerous ways of writing your components. Things like hooks, Redux, I don't know, prop drilling, using classes, using functions, using, I don't know, many other things. So you could just take that plugin and just compile your way of doing things. So a bit of epilogue here. Even though getting the results that you just saw, it's, by the way, on the GitHub. You can check it out. You can play with it. So even though achieving that was not that easy, I mean, I had to make a lot of the things out of the documentation of the mitosis. But the thing is that it's in very early stage. And I think that such approach to the development has a place in our hearts and in our daily cycles, because it gives us way to avoid a lot of the headaches that we are having right now. And it's true that you might be switching efforts from coding components to the coding adapters, but the thing is that if those libraries are popular enough, you don't have to write any kind of adapter. You just Google. You're just one Google link away from the solution. What was the last time that you Google something and there were 0 results, right? If it's popular, you most probably have result. And the thing with the adapters is that I'm not sure, I don't know exactly, but I think that during the history of the JavaScript boom, there were a bunch of the frameworks and the groundbreaking new approaches to the development that did not flow, that did not get the popularity that it should have got, because it was hard to start, it was hard to popularize, and when new boy comes into the school, it should prove itself worthy. And the thing is that to prove yourself worthy, you should have third-party stuff for you. And with things like these kind of adapters and plugins, we could have achieved that, and many genius ideas could have been saved. So thank you for your attention. This is the GitHub link I mentioned. You can quickly scan it to go there. If you have any questions, you could ask here, but if we don't have enough time, you can reach out to me anytime.